Hello, COP 2220 students. Dennis here. I'm going to discuss disjoint dynamic memory. So what I'm going to do is write a little program using disjoint dynamic memory and basically just learn how to use it and what it's all about. Here's some notes for you. When you learned about arrays in COP 20 or in COP 1000, you learned how to create an array on the stack. Maybe back then we didn't call it the stack, but that's what happened. And when you learn to create an array on the stack, you learn that an array on the stack must have a constant size. The size of the array must be known at compile time. Major drawback of an array on the stack, and also the array in the stack must exist in contiguous memory. Well, during our time here in COP 2220, we introduced the concept of the heap and dynamic memory allocation. We learned that the size of dynamic memory array could be user provided during runtime. Instead of as a constant, we can create the array using a variable. Recall that an array in contiguous memory cannot exist with any fragmented data in its way. So I need everything to be wide open. I can't have defragmentation of memory, or I may not be able to allocate an array. This will cause the program not to be able to allocate the array even though there might be a ton of memory available, but due to fragmentation you can't use it. Now we're about to learn about allocating disjoint dynamic memory. With disjoint dynamic memory, you'll be able to ask the user for the size of the array at runtime, and you'll be able to use all of RAM regardless of fragmentation. You see, there's no contiguous memory requirement. This is done by using an array of pointers. You will create an array of pointers in contiguous memory. The array of pointers will store pointers to other areas in RAM. Each element in the array of pointers requires only 4 bytes of RAM, so it's way more efficient. You'll be able to use all or most of the RAM available. So let's pretend this worksheet here, this Excel worksheet, this black area, this like out in the dark sky, is RAM. And each of these locations in RAM, each of these locations, for example, that yellow area would be a place to store data, a place where data can be stored. And we could store data all over the place. We could store it here, 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 here. Not in one, I don't need this one contiguous location. How am I going to get away with that? Well, this guy right here is an array on the heap in contiguous memory. This array that's on the heap, and this is just a visual of it, does not store data values, but it stores pointers to other areas on the heap where data values are stored. So at sub-0 is going to be an address of data somewhere on the heap. Data somewhere on the heap. Well, let's assume this is my array of pointers. So I'll just call it a pointer array. And if I issue a calloc size of maybe some struct, one thing and only one, that would create this many bytes of RAM somewhere on the heap and put that address right here. So for example, what would happen is this would create an address, and that address would go here. So once we execute this command, go away. Once we execute this command, somewhere out here in RAM is going to be an allocation of space. That allocation of space could have an hexadecimal address. Such as, let's just make it white, such as 0x3345. If that was a hexadecimal address, that address would be brought back here and stored right there. Stored right there. And if we allocated additional RAM, that would have an address, and that would have an address, and this guy would have an address, and this guy would have an address. And notice these are not contiguous, completely disjoint. I can go way out in the far ends of the heap, grabbing any piece of data or any piece of the RAM where I could store data. Every time I allocate, I will increment my pointer array down one, and the next thing is going to go here. So whatever that next address goes here, the next one goes here, and here, and here, and here, and here, and so on. So when I'm done, so as I as I push information onto the heap, as I start to allocate these spaces, the addresses are going to be populated in this array. So this array, just like any array, I traverse up and down the array using the index, and that's how I keep it all together. I like to maybe think of this array as a table of contents to maybe a book. Inside the book on some page is some piece of data. I come here to the table of contents, I find that location, and I look it up.